In this example, we're asked to use polar coordinates to find the volume of the solid inside the sphere x squared plus y squared plus z squared equals to 16, and outside the cylinder x squared plus y squared equals to 4. So we see from the drawing that we have the sphere, and inside the sphere passes the circular cylinder. And in this case, the first thing that we'll need to do is we'll need to find the region of integration. And to do that, we'll have to find where the sphere x squared plus y squared plus z squared equals to 16 intersects the xy plane. Which happens when z equals to 0. So setting z equals to 0 to the equation of the sphere will give us the circle x squared plus y squared equals to 16. We also have the intersection of the circular cylinder with the xy plane, which is exactly the same equation, x squared plus y squared equals to 4. So from these two, we can draw the region of integration, which will lie between the will lie outside the circle x squared plus y squared equals to 4, and inside the circle x squared plus y squared equals to 16. So this is the region of integration R. So the region R is a set of all points r comma theta, such that theta takes values between 0 and 2 pi. So we have the whole area of R between 0 and 2 pi. And then R takes values between square root of 4 and square root of 16. So R takes values between 2 and 4. One more thing that we need to consider is that in order to evaluate the volume, we will take the part of the volume that lies above the xy plane. So, and then we'll double that volume in order to account for the whole volume that lies both above and below the xy plane. So for that, we'll need, since we take the volume that lies above the xy plane, z would be either positive or 0. So if we solve the equation of the sphere for z squared, we'll have that z squared equals to 16 minus x squared minus y squared. So we take only the positive part of that. So z would be equal to the square root of 16 minus x squared minus y squared, which corresponds to the part of the sphere that lies above the xy plane. Therefore, the volume would be equal to 2 times the double integral over the region R of z times dA. And that would be equal to the 2 times the integral, theta goes between 0 and 2 pi, and the integral where R goes between 2 and 4, so integral from between 2 and 4 of z, which is equal to square root of 16 minus x squared minus y squared times dA, which is equal to R times dr times d theta. So this is equal to 2 times the integral from 0 up to 2 pi and the integral from 2 up to 4. And now we have 16 minus x squared minus y squared will give us minus x squared minus plus y squared, and this is equal to negative r squared. So we'll have the square root of 16 minus r squared times dr times r times dr times d theta. And we can split now in two integrals, one as a function of theta and one as a function of r. So we'll have 2 times the integral from 0 up to pi of just d theta, and then times the integral from 2 up to 4 of the r times square root of 16 minus r to the square times dr. The first integral is easy to evaluate, but for the second integral, we can do a u substitution. Setting u to be equal to 16 minus r squared will give us that du is equal to negative 2 times r times dr. So that gives us that negative 1/2 du is equal to dr. And from the first integral, we get 2 times the integral of d theta is equal to theta, and we need to evaluate that between 0 and 2 pi. And then we have, from the u substitution that we have to do, the second integral becomes integral of negative 1/2 times u to the 1/2 du. So that gives us 2 times the negative 1/2 from the second integral times theta evaluated between 0 and 2 pi will give us 2 pi minus 0. And then we'll have integral of u to the 1/2 du gives us 2/3 u to the 3/2. I don't put any bounds for now. I will put bounds when I switch back to u to 16 minus r to the square. So that will give me 2 times negative 1/2 gives me negative 1 times 2 pi will give me negative 2 pi. And then I have 2/3. And I switch back u with 16 minus r to the square. So that will give me 16 minus r to the square and all to the 3/2. And this needs to be evaluated between r equals to 2 and r equals to 4. So that gives me, from the first two terms, I have negative 4 pi over 3. And then for r equals to 4, I'll have 16 minus 4 to the square is 16 to the 3/2. And then I have minus, for r equals to 2, I have 16 minus r to the square, so 4 to the 3/2. So I get negative 4 pi over 3. And then I have, from the first term is equal to 0. And the second term is 12 minus 12 to the 3/2. So that gives me negative 4 pi over 3 times the negative, and now I have 12 times square root of 12 here. So that will give me 4 pi over 3, the negative with a negative is positive, 4 pi over 3, and then I have 3 times 4 times square root of 12 will give me, if I simplify, 16 pi times, so will give, it will give me 16 pi square root of 12. And I can simplify that a little bit further, and that will give me 32 square root of 3 times pi. So the volume between that lies inside the sphere and outside the cylinder is, the circular cylinder, is equal to 32 times square root of 3 times pi.